The first example I show you stands for the first principle, the integrated design. You probably have heard or seen the video about Pfingstweidschule in Zurich, which is a project from the city municipality. Actually, this is an example for a good integrated design because the city itself set up a competition for planning team. The planning team had to be complete from the very start of the first idea to win this competition as a planning team. That means that architects and engineers, together with wood architects, civil engineers, the building services engineers, building physicians, and actually landscaping architects, they had to come together and work on eye level. There was no gap in the required professional skills here. Only with a joint concept, with timber construction, mechanical ventilation, which was regulated according to CO2 level and demand controlled. You see that in the other video. Only together they really could solve that design problem here. And they were awarded to really carry out planning and construction. And what you see in 2019, this building was successfully given over to operation. And it comes close to a net zero building already. The second example stands for the second principle, which means to have control on the solar radiation on site. This project here is actually in the Caribbean coast of Colombia, and the improvement of the thermal insulation of roof level together with natural shading, that prevents actually this building for overheating. A better insulated or even green roof surfaces, you probably do not know that, but in every building on Earth, 2/3 of the whole energy will be absorbed by the roof. Even though in colder you will lose a lot of energy, but in hot tropical area you will gain a lot of it. So 2/3 of the energy demands come from the roof. So if you can cool that down, your matches actually have a big step towards net zero. Then additional natural shading by using the eaves of the roof, by using balconies to avoid direct solar radiation on the facade. And then with active shading and better glasses, you do the rest on the envelope. This combined with some measures in the surrounding, I will come later with another example, or measures you really can improve and prevent from solar overheating of the buildings. The next example is also a school. The state of Luxembourg in Europe demanded for a lighthouse project which included the energy over a life cycle. They wanted to have a solution where a building actually over operation brings back or gains back the whole energy who was invested during construction and will be invested in reconstruction. That was a real life cycle net zero building already built. The result here is this school here, which is a wooden construction with a solar roof, which actually allows to really pay back the invested energy. It is a very good example for an already existing net zero building. By the way, it's multiple award winning in Europe here, a very good example for a school. The next example I show you is an office building. Office building, the investor is this, Swisscom, is a telecommunication provider here in Switzerland. This office building hosts 2,000 workspaces. It is near a highway, so there is a lot of noise and dust there. And it's an example how to use natural ventilation together with mechanical ventilation using the atrium of the building as a lung. So we provided night cooling, night shift. We had the soil underneath the building as a thermal storage and the cooling source. And it resulted that the energy demands for mechanical ventilation was at lowest level. Using the lung means that the adjacent rooms, they actually took their fresh air from the atrium and only when people are really in the room. So this mechanical ventilation is only in operation when rooms are occupied. In the result, this is a new benchmark for low energy demanding ventilation. It also was a multi-award winning project in terms of energy efficiency, high comfort and lowest investment. So let's come to the next principle, an example which reflects the principle number 9. What is the meaning of integrating the outdoor spaces into building design to avoid heat islands in the surrounding with an impact on comfort for people who stay there and on the energy demand of the building at the end of the day. The goal is actually to avoid sealed surfaces in the surrounding. That allows for a better water management, allows trees to grow, because trees, high-growing trees, reduces the possibilities of heat islands in the surrounding. They provide shading not only for the people who stay outside, but also for the buildings that reduces the energy demand at the end of the day. So a good microclimate in the surrounding is a key figure towards net zero buildings at the end of the day. The next project I show you is an example about the value of the 10th principle, that electrical equipment in the building, they need to really meet highest standards. But they are not only the energy demand, the energy efficiency of those electrical appliances and the lighting systems. Actually, in this 5-star hotel in Zurich, that was a separate goal we had to reach, and we used movement sensors, daylight sensors, and standby killers to really keep down the energy demand and only being used when people demands for it. In this 5-star hotel, it was one of the main issues of our consulting job. Without lowering the demand of such devices, actually the exercise to become a net zero building will be even more challenging to reach. The next example is the value of the generation of renewable electrical power on site. This example here is actually our own office building in Berlin. It already has a high efficient thermal envelope, and the thermal energy for cooling and heating were drawn from the groundwater in this canal you see here nearby. But what you don't see is, and you see that on the next picture, the roof of the building is hosting a huge photovoltaic system. That allowed us to cover actually a big part of the annual electrical energy demand on site. And so at the end of the day, we fulfilled already the actual highest label of sustainable building in Germany, which is DGNB platinum level. That's coming very close to net zero building for offices. The last principle I wanted to explain to you is the monitoring, the 15th principle. This picture here shows an investment project by the Swiss railway company here in Zurich at the Europaallee, which was meant to be a lighthouse on sustainable buildings. It hosts a hotel, with elderly apartments, or apartments for elderly people, and office spaces actually rented by Google, and also a commercial space and a cinema complex. This project was to set new benchmarks as a lighthouse in sustainable buildings. And therefore it was mandatory from the beginning to install the framework of sensors and measuring equipment to constantly measure the energy flows in the building, frequently and automatically analyzing the performance and monitor the performance compared to the expected benchmarks. So the operation team here is able to react when the performance is leaving expected boundaries in operation, and it allows them to detect failures and unexpected user behavior early. And that builds the basis actually to rely and maintain a net zero building in operation. This is actually something which is very important if we come close to net zero buildings. So thank you for having me for some insights. There are some lessons learned of my life I would like to share with you. First is, I deeply believe and I know net zero buildings are already possible, but it's a challenging goal. The second one is, as being part of the building sector, we have a clear target, a vision to become net zero. And we can actively contribute as architects, engineers, and investors to that solution. We must not remain being part of a problem. We can contribute to be part of a solution. But what we need is, we all need to have a holistic view and constantly enhance our knowledge about energy emissions over the whole life cycle of a building. This is lifelong learning. The next one is, that's teamwork. It's not something an architect or an engineer can solve. We have no Tesla here. What we need to do is to work in interdisciplinary teams, work together on an equal footing, and everyone needs to recognize its own contribution to reach this goal. At the end of the day, it needs persistence. We must reckon and deal with conflicting goals during the whole process. It's a search for the feasible way to the goal. We need persistence to walk this way to reach that finally. And I hope I had the chance to motivate you to really go further on this path. Thank you so much.